Hello, we will now talk about the material chapter 8, section 1. Chapter 8 deals with confidence intervals for proportions. And so chapter 8, section 1 is basically just to introduce you to the terminology and the basic concept of what a confidence interval is. And then section 8.2 is making a confidence interval with one population situation, one proportion. And then section 3 deals when you have two populations. And so we're making a confidence interval for the difference in their proportions, kind of similar to what was going on in chapter 7. But let me just in general explain what's going on with a confidence interval. So similar to what we had last chapter, we're going to have some population. So this circle represents an entire population. That's the whole group we want to know something about. And let's say our population here is all the voting age people in a particular city. And so let's pretend our population size is 100,000 people. There's 100,000 voting age people in a particular city. And so that's our big N. And so we want to estimate a proportion. Okay. And let's say the proportion that would say they're going to vote for a particular candidate. Now, in last chapter, we had sort of the unrealistic expectation is that we would be told the parameter, we'd be told the true value. But in this chapter and the rest of the year, for the most part, we won't be told that. We're going to have to estimate that with a sample. And so the only way we could find that proportion is to take a sample or to take a census of all 100,000 people. But what we decided to do is to take a sample to get a subset to try to estimate P, since we don't know what it is. And so this subset we call a sample. And let's say we take a good random sample of 500 people. It's very important that we get these people randomly. And so that represents our subset, and we find the proportion they're going to vote for. Let's say they're going to vote for this candidate. And let's pretend in our particular sample, we get that 185 of them do. Okay. And so that's our X, our number of successes out of 500. So our estimate, as we say, our P hat is going to be 185 out of 500. And so that is equal to 0.37. That is our estimate of P. Now, we know just because of sampling variability that this P hat is almost certainly not going to exactly equal that. So the concept of a confidence interval is as opposed to just reporting this value, what we're going to do is we're going to report an interval of values around it and then say we're whatever percent confident that P is actually in this interval. So what we'll do is we'll take our estimate, 0.37, that's our estimate of P, and we're going to add something to it and subtract it, something that we call the margin of error that we will calculate this chapter. That's just how much our interval is going to the left and to the right. And so let's just say for this particular interval, and we are creating what we'll call a 95% confidence interval. We'll explain all this later. But let's say we get 0.042. So, and that's our margin of error. So our interval would thus be this. So 0.37, so we'll say 0.37 plus 0.042. And so that is equal to 0.412. So that is our upper value, 0.412. And then we go 0.37 minus 0.042. And so that is equal to 0.328. And so that is 0.328. And that is a confidence interval. It's just taking an estimate, what we call a point estimate, and going a little to the left and a little to the right. And then we're going to say, these are the plausible values for the parameter, for P, the proportion of all the people that would say they're going to vote for the candidate. So, and we'll have a confidence level that we'll talk about. And what we'll end up saying is, let's say if our confidence level is 95%, and that'll be given in the problem, we would then say we're 95% confident that this interval captures P, the proportion of all the values. So the plausible values that would say they'd vote for this candidate is between 32.8% and 41.2%. Any values outside this interval, we'll say they're not plausible. Not that they're impossible. We're just saying according to this interval, they're not plausible. So if someone makes the claim that, hey, I feel that 43% of people are going to vote for this candidate, we would say, well, that's not really a plausible value. It's possible, but it's not really plausible. And so that's the concept of a confidence interval. So let's write down some definitions here. And so the first thing, what is a confidence interval? It is an interval of plausible values for a parameter, be it P or mu, based on sample data. And so those P and mu are the two main parameters. Now there's lots of parameters in stats that we talked about. There's standard deviations. You could have the population median. You could have the population 40th percentile. There's almost an indefinite number of them. But the main two we're going to study is P in this chapter, and then in future chapters, we're going to study mu. And so it's just a list of plausible values for P based on sample data, based on our estimate. And we're going to use P hat to estimate P and X bar to estimate mu, just like we did in the last chapter. So what is our estimate, our point estimate? It's just a statistic that estimates a parameter, which we had that in the last chapter too. So our P hat, our sample proportion, just like we talked about, it is our point estimate for P, and X bar is our point estimate for mu. So whenever you ask, what's the point estimate? All right, you will report either P hat if it's a proportion or X bar if it's a mean. All right, so where will it always be? If it will always be in the middle of the interval. Okay, so for instance, let's just pretend that they gave you an interval. Let's pretend the interval is like 0.28 to 0.36. There's the interval. And so those are the plausible values for our proportion. Where's the point estimate? It's at the midpoint. So what you would just simply do is you just find the midpoint of those other two endpoints there. So you'd say 0.36 plus 0.28 divided by 2. And so that should be equal to 0.32, I believe, 0.32. Right, like that. So that's how you find the point estimate. Just find the midpoint of the interval. And which, by the way, so that's what we call the point estimate. Now, the margin of error, as we discussed, is how far left and right this interval is going, okay? So to find the margin of error, so we know 0.32 is in the exact middle. So what's the margin of error? It's the distance between the middle and the outside. So to find the margin of error, we could just say 0.36 minus 0.32, and that's 0.04. And so you'll notice it goes 0.04 to the left and to the right there. So that's how you find the margin of error. Or the other way of finding the margin of error is just subtract those and divide by 2. You could just say 0.36 minus 0.28 divided by 2, and that is equal to that. So anyway, okay, so that's that. And then here's our formulas. Now, your formulas are really going to be more of an issue for later in the chapter, and we're going to talk more thoroughly about it. I just wanted you to be aware of them. And all right, so the formula for a confidence interval, we go to Mr. Formula Sheet, right? And so there's Mr. Formula Sheet. Let's look down here, all this nice stuff that we've done. And so this is on the first page of the formula sheet, and there it is. So there it is, confidence interval. Every confidence interval we're going to do has this basic generic formula. It is the statistic, for our purposes, either P hat or X bar, plus or minus what we call a critical value, which is going to be our Z star or T star, and then the standard error that we are going to talk about. Okay, and so it's always going to follow that formula. And so that's our basic formula for that you can get on the formula sheet. It is any confidence interval statistic plus or minus critical value times the standard error. And so for proportions, which what we're doing this chapter, so means is in future chapters, but our statistic is P hat. Our critical value is what we're going to call a Z star. And we can find that off of a table, and I'm going to show you how to do it. And or you can actually use your calculator to find it. And I'm going to show you how to do that actually in another video. And then there's the formula for the standard error. No, you remember that? What does that look like? What does that look like? That, you may recall, remember this guy here that we did in the last chapter, the standard deviation of the sampling distribution? Well, did you happen to notice what's right next to it? The standard error. All right, it's very similar, but as opposed to a P, we are using a P hat. Well, why are we using P hat instead of P now? Because we don't know P now. Last chapter, they gave us what P was. Okay, so we could use it. In this case, we don't know what P, so we're using P hat. So we no longer call it the standard deviation, we call it the standard error. And I don't like that word because standard error makes it seem like you've done something wrong, but like it's an error. So whenever we use an estimate, a P hat or an X bar or an S over here, we refer to it as the standard error. So that's where we got that formula. So there's the formula for the confidence interval for proportion that we're going to do this chapter. That's mainly the subject for section 2. And then there's the formula that we're going to be doing in future chapters for that statistic plus or minus, and our critical value for a mean is going to be T star and then S over the square root of N. So there's our little formulas. And so what is a critical value? The critical value is just the number of standard errors your interval is going to the left and to the right. And so let me show you how to find the Z star. So using your table. And so what we're going to do is we're going to go to our tables, which is in the same packet as your formula sheet, right? And so there's table A. We're going to go to table B. Even though it says T distribution critical values, to find our Z star, we're going to go to the bottom of this sheet. And in each problem, you're going to be given a confidence level. 95% is probably the most common one. It could be 90%. It could be one of these down here. It's never been on the exam that they didn't have one that wasn't down here. And like I said, I'm going to show you how to do this with your calculator in a future video. But these numbers that are right above it, where there's an infinity there, that is a Z star. So the Z star for 95% is right above at 1.96. The Z star for 99% is right above at 2.576. The Z star for 90% is right above at 1.645. So most of your intervals are going to be one of those three things, but it has others as well. So that's how you find, in essence, a Z star. All right, so what is the standard error? Well, the standard error is, in essence, sort of a very similar thing as the standard deviation of the sampling distribution. And there's the formula for them. All right, and so here's the one in this chapter, the square root of p hat times 1 minus p hat over n. And once again, you can find that on your formula sheet. Standard error of the statistic is there. And so that's going to be in section 2, really, and that's going to be in section 3. And this is in future chapters if it's a mean. Okay, so anyway, similar stuff to what we had when we did the sampling distribution chapter. And then the margin of error, the formula for margin of error. The margin of error is just critical value times standard error. Critical value times standard error. So for proportions, the margin of error is Z star times the square root of p hat times 1 minus p hat over n. And then there's in T star times S over the square root. The margin of error is the distance that the interval goes to the left and to the right. All this we're going to work out more completely in section 2 and section 3. I just want to introduce you to terminology that's going to happen. But what the heck, let's make a confidence interval. So for this one, let me show you how you would make a confidence interval with that proportion that we did before. So let's just pretend that we want to create a confidence interval. And like what we had before, we take a sample of 500 people and we ask them, are they going to vote for a particular candidate? And we get 185 say yes. And so our p hat is equal to 185 out of 500. And so that's equal to 0.37. So that's our p hat, that's our estimate. In these proportion problems, they can either give you the number of successes in the sample size, or they could just give you the proportion, 0.37 in the sample size. And so the formula for our confidence interval, as is up there, as is right there, is going to be p hat plus or minus Z star times the square root of p hat times 1 minus p hat over n. So our p hat is 0.37. Our Z star, and let's pretend it said create a 95% confidence interval. Create a 95% confidence interval. So what we would do is we would go to our table B. We would go to table B and go to, table B, right? Table B. And so then we would go to 95% right there at the bottom, and we look and it's 1.96 right there. And so that's our Z star, 1.96. And so then we would say the square root of, and that's going to be p hat is 0.37. 1 minus p hat, that'd be 0.63. All right, and then our sample size is 500. And so this ends up being, so when you multiply that out, 0.37 plus or minus, and this ends up being 0.042319, okay, with plenty of sig figs. That is what we call a margin of error, okay? So that's important. It's a frequent question to ask, hey, what's the margin of error? And it's just Z star times that. Or like that little thing I did before to find the margin of error. If you're given the interval, you could just subtract the 2 endpoints and divide by 2. So, so either way. And so then if we go 0.37 plus that, and so that would be approximately 0.412, I believe. And then if you go 0.37 minus that, it's approximately 0.329. And so then, like we said before, the conclusion, if you're asked to interpret that interval, we would say, I'm 95% confident P is in that interval, okay? And so, P being the proportion of all the people in the county that would vote for this candidate. And that leads me to this, okay? So what does it mean to interpret the confidence interval? And it means you're going to write this statement. To interpret the interval, you're going to say this: I am blank percent confident, whatever's given in the problem, 99%, or in this case, it was 95%. I'm 95% confident, whatever, that this interval captures the parameter. You're going to say that every time, but you have to say it in context and define what the parameter is. In other words, in this particular case, you would say, I'm 95% confident that this interval, and say what the interval is, by the way. In this case, it'd be 0.329 to 0.412, that this interval captures P, the proportion of all the people in the city that would vote for the candidate. All right, that's what is known as interpreting the confidence interval. And then we have what is known as interpreting the confidence level. And I'm going to show you what we mean by that. Interpreting the confidence level, all right, so that means if we did this same procedure many times and made many intervals, 95% of the intervals would capture the parameter. And let me show you what I mean by that. So let's say if we have some interval, okay? Or let's say if we have some parameter, some P that we're estimating, and we make an interval. Now our X bar, or I'm sorry, our P hat is not going to exactly equal to what P is, okay? It's going to be, and so it's going to be a little bit off. And so what we do is we go a little bit to the left and a little bit to the right. That's our margin of error, and make an interval. But what if we took another sample and from the same population, same sample size, and found another P hat? It's going to vary from that just because of sampling variability. And it would create another interval. Notice both of these intervals capture P. P is within the interval. And if we made many intervals and made many different P hats, okay, many different P hats like this, and you'll notice these capture P, but every once in a while, this is going to happen. You notice this particular interval, just by chance, did not capture the true value, okay? All right, and so what a 95% level of confidence means, it means if we made many different intervals like this, if we kept going on and on and on and made a large number of intervals, 95% of the intervals would actually capture the true value, would actually capture P. If it was 99% confidence, we would say 99% of the intervals would actually capture P. And so that's what this is. That's what this is saying there. If we did the same procedure many times and made many intervals, 95% or whatever's given in the problem of the intervals would capture the parameter. And you say what the parameter is in context, okay? In other words, P, the proportion of all the people that are going to vote for this candidate. Now, I included another, you may have noticed in your sheet, I included another question there that I wanted to answer that is sort of an important issue. And so I wrote that here. All right, so what can we do to make the margin of error smaller? Okay, that's an important concept. All right, because sometimes we can make an interval that's so big and it's not satisfying. To make your margin of error smaller, you can increase the sample size, or you could decrease the confidence level. Like when you look at our formulas for margin of error, notice how N is on the bottom. And so our sample size is inversely related to the size and the margin of error. The bigger N gets, the smaller the margin of error is. Okay, that's a very important thing. And in fact, they're inversely related by the square root of the sample size. All right, so if I wanted the margin of error to be half as big, I would have to multiply the sample size by 4. If I wanted the margin of error to be, a third as big, I would have to multiply this by 9. It's inversely related by the square root. But the other thing we could do is we could change our critical value, and we could change the Z star, and you change that by changing your confidence level. And in general, the more confident you are, the bigger this is. So a 99% confidence level is going to have a bigger Z star than a 95%, which would be bigger than a 90%. So if you want your interval to be smaller, you could have less confidence. Just if you increase it to 80%, your Z star will be really small. But the trade-off is you're going to be you're going to be less confident that it actually captures the true value. So so that is that. All right. So I want to so that's the basic terminology of the chapter that we're going to be doing. The stuff in section 2 and section 3 to try to master this stuff. But let me show you an example of the type of situation that you could be facing, and so let's look at this here. So this says right here. All right, so a scientist wishes to estimate the proportion of deer in his county that have a certain disease. He takes a simple random sample of 300 of the deer and finds that 63 of them, which is 21%, have the disease, creating 95% confidence interval. So he creates a 95% confidence interval that has a margin of error 0.0461. So it gives us the actual interval. So what is the interval? Well, the interval is going to be 0.61 plus or minus 0.0461. So when you're given the margin of error like this, you just go the point estimate, 0.21 plus that, and 0.21 minus that, and there's the interval right there. Okay, there's our confidence interval. Those, in essence, are the plausible values for P, the proportion of all the deer that have the disease. We found 21% in our sample, but we know the population value is going to be different from that just because of sampling variability. Okay, so these are our plausible values. So those are our plausible values for P. All right, so then it says, it has been claimed that 15% of all the deer have the disease. What does this interval tell us about this claim? Well, 15% or 0.15 is not in the interval, and so it's not a plausible value for P, which is the proportion of all of the deer in the county that have the disease. Okay, so it's possible, but it's not plausible, is what we're saying. Okay, so it's not impossible that it could be 15%. It's just really unlikely, or the word plausible is a good word. And so the next one says this. Someone else claims that the interval provides evidence that exactly 20% of the deer in the county have the disease. What would you say to that person? Well, 20% is in the interval, so it's a plausible value, but there's lots of plausible values in that interval. So 0.2 or 20% is in the interval, so it's a plausible value for P. But there are many other values in the interval as well. So this does not provide evidence that 0.2 is the true value of P. Okay, it's just saying it's plausible. It's not really evidence for it, as we would say. And so then interpreting the confidence interval, if you're asked to do that, like we just talked about. And so this is the way you would interpret the interval. We would say, I'm 95% confident that the interval captures P, the proportion of all the deer in the county that have the disease. And so that's how you interpret the interval. You're always just going to say, I'm whatever percent confident it is, and say the interval, that this interval captures the parameter, and then say what the parameter is. Okay, there we go. And interpreting the confidence level, that's different from the interval. Don't get those two things mixed up. So if we were to do this same procedure many times and made many intervals like this, 95% of the intervals would capture P, the proportion of all the deer in the county that have the disease. And then lastly, someone wants to make the interval half as wide. What should he do in regards to the sample size? Well, he should multiply it by 4 to make it 1,200. It was 300, so you multiply it by 4 to make it 1,200, since the margin of error is inversely related to the square root of the sample size. Okay, that's your little introduction to Chapter 8 with Chapter 8, Section 1. So please read your book and think about this stuff and send me any questions. And I just hope you have a great day.